I'm Christoph Schiffers. Good afternoon to the people here in Europe. Good morning to the ones in the Americas. And thanks for everybody who is organizing this. Special thanks to Melanie and Nikos, who act as the directors. So please feel free to post your questions. And this here is about your questions, about your cutting tools in the chat. Please be aware that the chat is public to everybody. So if you would like to discuss something in a one-by-one communication, then you see now an email address. Please send us an email and we will react on this and go into a direct communication. Other option, of course, is also doing a live batch, doing a coating run with your cutting tools in such a device live, either here in Aachen and in Germany, or with our colleagues in Horses in upstate New York. There's the same equipment and you can really experience coatings and not just see it on the screen, but where you can touch it, you can feel it. Well, to bring us into the topic, and I see the team is already working on the first questions which are flying in, I would like to start with a very small introduction to bring us all on the same page and into the topic. You are a tool maker, and you know that a high-quality cutting tool needs 3 ingredients: the substrate, the geometry, and then comes the coating. And we would like to show you how this few microns on top, this little bit on top of your geometry, will change the game and will help you to boost the business. And well, I think you will agree, you as a cutting tool expert, that only a coated tool is in the final and the perfect product. And the whole thing is about joining your competence as a tool manufacturer with our competence as a coating company. And all together, we will form up a result which gives a benefit to your final customers and in the final end helps you to improve your business.
So we already have the first question,
Good.
And it seems to be a very urgent one. Availability and lead time for spare parts.
Yeah.
Probably something that has been asked by lots of customers.
Yeah. That's a very important question in the moment because, well, you all have probably experienced how difficult supply chain situation is in the moment. The good thing is this device is really made here in Aachen. Here in this premise, we have a huge job coating center, actually the biggest one for cutting tools in the world. Machine building and R&D in the same place. And all the equipment we are building here is designed here and is made here. And the key suppliers are just coming around, let's say, 100 kilometers. And we know that such a machine is vital to your production. So we have a huge stock of spares, which is a very big help, especially in the given situation where getting components might be quite an issue. So don't be afraid, we have a huge stock, and in 99% of all cases, we ship within 24 hours and you get a spare part so that your machine is back on stage.
Next question comes from Laura, and she wants to know what distinguishes silicone coatings from others.
Interesting question. Thank you, Laura. Well, when it comes to a coating, it starts with a chemical composition. Titanium, aluminum nitride, aluminum chrome. This you can do with a lot of technologies. It becomes very different when we're transforming the chemical composition into physical properties. Then comes here this buzzword high PIMS into the game. High PIMS, high impulse sputtering. It gives a fine-grained morphology, dense coatings without any droplets, and this changes the game totally. A different set of physical properties give a known composition a fully new meaning on your cutting tools. So here we have something which distinguishes semicon from all the other people in the cutting, in the tool coating world. And the third thing is what we call engineering. The way how we apply a coating, and coating is a process which starts after grinding with cleaning of the tools, with edge preparation, for example, blasting. All these details like how to batch something, what to put into one chamber, all these things we have detailed in 35 years of experience. And a very special or very important thing in this is the preparation and the evaluation of the cutting edges. And here I would like to show you a little bit on here a drill. The cutting edge of the drill, you see, this is, well, not perfect. Something could be done about to make it better in the performance of the tool and to help the tool that a good coating, here you see quite some deficits on the cutting edge, that the coating can unleash the full power when we do something about making the cutting edge more homogeneous. And one possible solution for this is edge honing and a little bit of making the cutting edge homogeneous by wet blasting, for example. This is a technology which we normally use for carbide cutters to support the cleaning and to make the cutting edges more homogeneous. That's what you're seeing here, this nice animation of round, the typical air-style inserts. On the left-hand side, a perfectly ground and honed insert, but still you have some marks, some scratches in the cutting edge. And on the right-hand side, you see after wet blasting, the cutting edge is by far more homogeneous. And of course, this is a big benefit when it comes to the performance of your tool together with the coating. So this is a big benefit or a unique thing of Semicon. From all our experience, we know how to convert a very good cutting tool into a perfect one and then apply the coating. And this technology, we are more than happy to share with you and to transfer it to you.
Next question. We would like to be more aware about HiPIMS technology. What is the pros and cons about this technology?
Yeah, very important thing. Well, when we go back into the history of PVD coatings, the first technology was arc deposition technology. It means you run an arc on a target. The arc melts the material, evaporates it into the plasma. The big disadvantage of arc technology is that you always have droplets, unmolten particles in what you see on top of the coatings, and you have these voids in the coating. The other thing in arc technology is you have a tendency to high stresses in the material. The other technology is sputtering. The same thing happens here like in a light bulb. You take a target and you bombard it with gas ions, and you take the material out atom by atom. The big thing in HiPIMS is high impulse sputtering. You do sputtering with way more energy in the pulse. So you take the advantage of sputtering, a droplet-free smooth coating, and you apply more power, which helps you to increase adhesion of the film. And here I think we have a very nice animation to show to you, to show you the differences in the technologies. Why is HiPIMS so different? Because, well, in this new technology, you have in the pulse high amperage and high voltage at the same time, which gives you a fully different level of power, ending up in a dense coating with a fine-grained morphology. I think also for this we have a nice thing prepared showing you what the benefit of the HiPIMS coating is. Maybe we could bring it in. Yeah, perfect. Thanks a lot. So what you see here, a 12 micron thick PVD coating, all the 12 microns through, a fine-grained structure, a fine-grained morphology. And the other message is 12 micron. Obviously, the other big thing in HiPIMS is managing intrinsic stresses. Otherwise, it wouldn't be fully impossible to do a coating as thick as 12 micron. That's a big advantage, either for thick coatings on inserts or when we are going to very tiny round shank tools for dental applications or for cell phone cutting. Then you have super small cutting edges which are extremely sharp. Also there is low stress, a dense coating, a big benefit.
Matthew wants to know, can you explain the adhesion of your coatings versus ARC technology?
Yeah, thanks for this question. A very good question. Why is Hypems gaining that much ground in the cutting tool world in the last months or in the last years? Well, basically, it takes the good things out of both traditional technologies. It takes versatility of sputtering. Basically, you can sputter every material. You can do it on CBN, you can do it on ceramics. You are smooth, you are droplet free, and it combines it with the conventional arc technology, or the advantage that you have lots of power giving good adhesion. Hypems has both advantages, or from both worlds, into one technology. And this brings us to a very important point today. The world is extremely unsecure, and it's very difficult to predict something. The most important thing is today flexibility. And with a Hypems coater, you can do any cutting tool, whether it's a micro cutter, what you see on the upper right-hand side, whether it's a tap tool, where you don't want to have any droplets here in the cutting edges, or you can do a 12 micron thick coating on a heavy-duty insert. Everything in one device, just by changing the recipe. So your investment is future-proof.
One question about costs. What about batch costs, consumption targets, electricity, gas?
Yeah, of course, an important question. Money is always important when it comes to production. With this unit standing behind me for a titanium aluminum nitride, ferrocon, our product name, the cost for electricity, gas, target consumption per run is €135. The machine can accommodate diameter 6, length 60, around 1,800 cutters, which brings us down to 7 to 8 euro cent per tool. The other big thing is that we found a way to make Hypems quick. 2 micron per hour deposition rate, which is unrivaled in the Hypems world, brings us to a door-to-door time of 4 hours 30. And the other thing is from the whole concept of the machine, changing from one batch to the next one, taking the old one out, cleaning the machine, changing targets, bringing a new batch back, can be done in maximum 30 minutes. So you can do with this thing 4 to 5 batches a day.
Next question, when is it worthwhile to coat by myself?
Well, also very important, every investment in technology needs to be well considered. Due to the importance of this question, you will find on our webpage a nice online calculation tool where you can play around with your numbers, how many tools you are doing, what costs you have today with job coating, and the system will give you some ideas if it makes sense for you to go into own technology, or whether it's for the time being for you is a better option to continue with job coating.
Nikolai wants to know, is Hypems as sensitive as ARC in terms of batch uniformity, shadowing, tip effect?
Yeah, a very interesting question you are asking. The other big advantage in Hypems is you have more parameters. In any conventional technology, you have basically power in terms of voltage and amperage on the evaporator, and you can play around, of course, with gas and composition. But in ARC, that's, I think, what you are addressing. You have lots of power, but it's very difficult to moderate power and to control power. Here, with the pulsation, you have the length of the pulse, the height of the pulse, the frequency. So it's by far easier to control power for a certain object. The typical thing, what you see in an arc coating, that on a cutting edge of an insert, you have some kind of an undercut because the field lines concentrate there, and over edge or damage the cutting edge. This you will not see in high PIMs because it's by far easier to control and to adjust power. That's the reason why for things like sharp grooving inserts or small, very pointed micro tools, high PIMs is by far easier to control than large machines.
Next question. Do you have any new developments related to decoating?
Yeah, decoating. Well, sometimes you need decoating. And in some cases, for example, for reamers or for hobbing cutters, is decoating a production process. There are some new developments, especially with controlling the process. Well, you know, decoating is you have chemicals in some kind of a tank, you put the tools in, and what we can do today better than before is controlling the temperature. Decoating is chemistry, and chemistry is driven by temperature. So with new control technologies, it's easier to bring it to a temperature level that decoating is quick, but that you can stop before you come down to the carbide, which is always a danger that you damage your carbide.
Your next question. Is high PIMs indicated to big tools, or is it not economically viable by the high cost of batch?
Mm-hmm. Well, big tools means thick coatings. And for thick coatings, you need to find a way to bring down stress. And that's what we managed to do with our way of making high PIMs, which means the evaporators, which are here on the side doors, are synchronized to the bias. So when it comes to big tools, big cutting inserts, for example, for railway manufacturing, typically 50 mil diameter, or large tool holders with braced inserts on top, I would always recommend this machine because the quality level you can achieve or the benefit for your customer with a thick coating is so high that you can charge for your tool way more than with a standard coating from a cheaper piece of equipment. So I think here it's about giving a benefit to your customer by technology.
A special question. At what coating thickness do you start to worry about internal compressive stresses becoming too high?
Yeah.
I'm asking in regards to recoating tools that have been reground and have coating on them already.
Yeah, of course, that's an important question. Of course, coating thickness is related to the radius of the cutting edge. And of course, to the question you are raising, how much coating is underneath. I would recommend for a quality reground, reconditioned tool, after some 3-4 cycles, you should decoat or should grind away all the coating. Otherwise, you add too many layers and you will get issues with delamination or flaking. The good thing here is that with the low stress in high PIMs, you are, let's say, less sensitive to all this. But again here, after some 3-4 runs, please decoat or grind away the material.
Next question. Are the coating recipes fixed? Is it possible to make changes?
Of course, changes are possible, and here in the controller of the machine is a pretty user-friendly software which helps you to adapt the coating recipes with a macro system. And that's one of the big strengths when you have your own machine. You can do slight changes. For example, adapting back to your question before, when you have tools which have, after regrinding, let's say, a small deficit in the surface, makes the coating probably half a micron thinner. In the final end, the product will be better because of better adhesion on the old surface. So yes, it's easy to change them, And to make it even easier for you, we have a fully open target concept, so you can run your targets for your product, your composition, and you can utilize the full power of sputtering. That's a full table of periodic table of elements can be applied to the coating chemistry.
Next question for you, Christoph. How many people do I need to coat?
Yeah, when you start as a tool maker, having, let's say, 15, 20 grinders, you would probably start with one coater. Then our recommendation is please take 2 people. The machine itself runs completely automatic and autonomously. But of course, for the preparation, the batching, the cleaning, the blasting, you need people. So with 2 people in the day shift, you can feed into the thing enough material for running 2-3 batches a day. The machine can be fully remote controlled, so you can watch it from your tablet computer, your telephone, if you want to do so. But again, it runs fully automatically and autonomously.
Getting back to reground tools, can silicon high PIMS coatings be applied to another company's coating?
Yeah, a very often heard question. When you have an unknown or different coating underneath, this is always a little bit tricky with each and any technology. So what my recommendation would be, please at least on the primary and the secondary phases, grind the old coating away. Coating on a different another material, let's say an altin on an altin or an aluminum chrome on aluminum chrome, this might work, or will work, but other compositions, especially very hard coatings, it's not fully easy, even with cleaning, blasting, and the plasma etching, which comes before the coating process itself.
At the moment, there are no new questions, so we wait till the participants set new questions.
So in between, maybe a good tip or an important tip or 2 tips from our experience. The first thing, 50% of the success in coating is cleaning. Cleaning. Very important to remove everything on the tools. We had some discussions about regrounds. Regrounds pretty often have residues from the previous machining or from the grinding. Please take care on the cleaning that all these residues are away. So what you are seeing here, a cleaning line, is a very important part in the workflow. And here we can help you with all our experience to give you the right advice for what machine or what cleaning unit you should use. The second important thing is when you are giving your tools to a job coater, probably having just 2 or 3 units, plus you set them under time pressure because your customer is waiting, then they need to do a compromise, mixing your probably small tools with the big tools from anybody else into one chamber, into one run, which of course is a compromise. You, as a tool maker, you know what tools are coming down your production stream. So for you, it's easier to have a uniform batching of, let's say, similar tools. Just this improves your quality. That's the same thing like when you put into your washing machine white socks and red socks. Afterwards, the white ones will be a little purple, what you don't want to have. So just by more uniform batching of just your tools, you get a better quality.
A new question. Getting back to the big tools, is there an equipment to circular saws with max 150 millimeters diameter?
Well, 150 millimeters diameter, absolutely no problem in this device. Table diameter is 400 millimeters for the high PIMS unit, so 150 millimeters will work easily. Of course, an important question is what we have to check. Is this a circular saw with brazed tips? Then we have to check for the standard thing, is the brazing material suitable for coating, so cadmium free, is the temperature okay, but from the geometry, no issue.
So at that moment, no more questions.
Okay.
We could come to the end because we're 10 minutes over, but
okay.
It's fine.
Which is good, and then showed is a good sign that it was a nice thing for you. So, first of all, thanks for your time and also for your patience because of the small technical glitch which we had. Thank you very much. The best way for going into coating or to experience what coating really means is ask us for your personal life badge here in Aachen or in Horseheads, upstate New York. There you can really see, experience, and feel coatings. You can see a lot of stories or success stories from our customers and end users on our YouTube and LinkedIn channels. And of course, when you have the chance to come to Stuttgart from May 17 on, we are on the Grinding Hub exhibition where you can join us. You can see there's the grinding people and of course, Semicon as the tool coating people. Thank you very much and have a great weekend.